Hello sir, my name is Audrey and today I will be presenting about my assignment to you. So let's start.
Okay, so now let's start. So the first thing we need to do is to draw a truth table based on the question given. So the question told us that we need to have a 3 bits input of A and B and also a 4 bits output of value A minus B. So this is the truth table that I have made. I color my truth table so that it's easier for me to transfer the data to my KMap. So this, as we can see, this is my input A, this is my input B, and this is my output. My input A, we have A0, A1, A2, and input B, B0, B1, B2, and output B out C0, C1, and C2. So I made my truth table based on the decimal way, at where A0 have the 4 value, A1 have the 2 value, A2 have the 1 value. Same with my input B, B0 have the 4 value, B1 have the 2 value, B2 have the 1 value. And for my output, this B out will tell whether the answer is positive or negative, and 0 is positive and 1 is negative. So for my output C0, C1, and C2, all these three same with my input. C0 have the value of 4, C1 have the value of 2, and C2 have the value of 1. So let me take one example for you. Let me take this number 44 as an example. So we in input A, we have 1 here and 1 here, so it's 4 plus 1, which is 5. And for input B, we have 1 here and 1 here, so it's 2 plus 1, which is 3. So after we minus 5 minus 3, we get 2. And 2 is positive, so we put our B out 0, and then we put 1 here because the value is 2, and here is 0. So after I completed my truth table, I continued with my KMap. This is my B out KMap. So since we have 6 variable, then we need to do the 4 variable for KMap. And for your information, all these 4 KMap are actually stacking each other. They are adjacent to each other, which mean like this 0, 1 table stack on top of this 0, 0 table, and this 1, 1 table stack on top of this 0, 1 and 0, 0 table, and lastly this 1, 0 table will stack on top of this 1, 1, 0, 1 and 0, 0 table. So what I do with my KMap is, first I find which group of 1 that I can circle between the same group of 1 that I can circle between these 4 table. So the first circle that I circled is this one, this group of 1 with this group of 1, and then I get my first equation. And then the second equation I get from this from this one box of 1, one box of 1, one box of 1, and one box of 1, and then I get my second equation. And then for my third equation I get from this 4 group of 1. And why you ask me why I don't circle this 4 group of 1 with this 4 group of 1? As I said just now, these 4 tables are actually adjacent with each other. So I cannot match this group of 1 with this group of 1, because between these two tables we have these two tables. So we cannot do that. Why I can do between this group of 1 with this group of 1, because these two of these two table is actually side by side, so that's why. So continue with my equation. My third table is from this table, and then my fourth table is from this circle, and then my sixth table is from this table, and then my 7 is from this circle, and then my last equation is from this circle. And then I get my equation for my B output KMap. After that, I do the same with my C0 Kmap output, and then with my C1 output Kmap, and then with my C2 output Kmap. After I get all the equation from these 4 output Kmap, I combine them all, and then I draw my circuit diagram. This is my circuit diagram that I have made. I made it from simple AND and OR gate. So after I draw my circuit diagram, I test it with the random input and input A and B, and then check the output whether it is same with my truth table. And since my truth table have 64 rows, so 20% from it is like 15, but I have provided 17 evidence here, 17 tests, which is all working, and you can see it, sir. So, oh yeah, if you cannot see it clearly, sir, my circuit, you can zoom it in because it's too small. So, you can see it clearly if you zoom it out, zoom in it. So, yeah, that's all from me. Thank you, sir.